Okay, so if you move 12 meters west in an electrical field, your electrical potential drops by 340 volts. What is this electric field? Here we go. Okay, so let's just think about this, right? If we move to the west, our potential drops. Okay, what that means is that we're not doing work on the charge. If we had a charge, right? The charge is doing work on us. That's what that means, right? We're doing negative work. That's what drops means here, okay? So that means that we're going in the direction of the electric field. Okay, if we go to the west, so let's see. Never eat soggy wheat. All right. Okay, so if we go this way, we're going in the direction of the electric field. So the electric field is this way. That means east is more positive, west is more negative. We're going toward the negative potential. Okay, that's what that means. And that means that the electric field is in that direction. Okay, so we know the electric field is westerly. It's toward the west. Okay, and then of course we're going to use this. We're going to use this formula here, right? So our electric field. And let's see if we can get the maths to give us a westerly number. We'll try our best. Okay, so it's the change in electrical potential over change in R, right? Okay, so it drops by 340 volts, right? So if we go move 12 meters west, so let's go negative, our change is negative 340 joules per coulomb, or volts, right? They're the same thing. Okay. And then our direction is 12 meters west, right? So our change in R is 12 meters west. Well, lo and behold, look at this. Look what's happening, okay? Notice that in the numerator we have a positive number. When we divide this out, we're going to get an electric field that's to the west because it's going to have the same direction as our R. Are our children learning? Okay, so here we go. 340 divided by 12. 28.3333. Okay, so here we go. So our electric field is 28.33 repeating, and that is, what is that, joules? That's going to be volts per meter, right? Or it's going to be joules per coulomb per meter, right? Or it's also going to be just newtons per coulomb, right? Because a joule is a newton meter divided by meters is just newtons, right? Volt per meter is just fine, right? Okay, and then this is to the west. So what is this electric field? What force does it exert on negative 56 microcoulombs? Okay, so now that's a whole nother story, right? So I'm going to use E as F over Q, right? So therefore, F is EQ, right? And that's going to be 28.33 newtons per coulomb west times negative 56 E minus 6 coulombs, right? Okay, so times negative 56 E minus 6, and that is, oh, look at that, okay. I'm getting negative 0.001586666666667. Okay, and that is newtons, right? And that is negative west. Okay, technically that's correct. That's an odd way to talk, right? So really we would say, I guess 1.59 times 10 to the minus third newtons east. Negative west is the same direction, though. That's kind of crazy. All right. You can do that. I would just do this. I mean, personally, if I know that the electric field is to the west, okay, I know that a negative charge will have a force to the east. I just know that. Okay, but the math also works. So these formulas are vector formulas, even though they're not written correctly sometimes. All right.